Section 3.4, the product and quotient rules. So let me first go over the theorems, and then we'll go ahead and do some examples. So first we have the product rule. The product rule is when we're multiplying two functions of the variable, and while expanding might be helpful, so you might have something like 2x plus 1 and 3x plus 1. So yeah, you can always go ahead and FOIL beforehand, but product rule might be a bit easier when something is not as easy as a binomial, right? So your product rule is you're going to multiply your function f and g, but the first time you're going to take the derivative of the first function, and the second time you'll take the derivative of the second function. Quotient rule is if you have two functions and you're dividing. Notice the top looks a lot like product rule. Your first rule is you take the derivative of the numerator times your denominator minus your numerator times the derivative of your denominator divided by your denominator squared. That produces the derivative. And of course, the power rule from the last section. Let's go ahead and go over some examples. So let's take the derivative of this function. Let me start off by rewriting it. So if I write it as b squared times 2b to the 1/2 power plus 1, it won't look so intimidating. So we know to use the power rule because we have two functions that are being multiplied. And just to remind you, your product rule says you're going to take the derivative of the first times the second plus the first times the derivative of the second. So that we have f prime of g plus f g prime, and you're multiplying them. So if this is your f and this is your g, let's go ahead and use our formula. So that I have the derivative of the first one is b squared, so that would be 2b. And our second function is just 2b to the 1/2 power plus 1. Plus, now I'm going to write my first function, which is just b squared, and take the derivative of my second, which is you bring down the exponent, so 2 times 1/2 b to the 1 minus 1/2, negative 1/2, plus 0. Okay, let's go ahead and clean this up. So I have 2b times 2b to the 1/2 plus 1 plus b squared times, well, that just makes 1. So we're left with b to the negative 1/2 plus 0, so nothing's there. Okay, now we can go ahead and multiply them out. We can distribute them. Now remember, your exponent rule, if you have the same base, then you just add the exponents. Okay, so we have that same base of b, so 2 times 2 is 4, and we have b. Think of this as 1, which is 2 over 2. 2 over 2 plus 1 over 2 is 3 over 2, plus 2b plus b, and then 2 minus 1, or 4 over 2 minus 1. You get 3 over 2. We actually have some like terms. So 4 plus 1, get 5b, 3 over 2 plus 2b. That is our derivative. That's our d dx. On to the next problem. We want to find the derivative of x cubed minus 8 times x squared plus 4. And yeah, you might be tempted to FOIL, multiply it out, but let's practice our product rule. So if this is our function f and that's our function g, our product rule is f prime times g plus f times g prime. Now, I know it's not so bad, but it's new to us. So every time you use product rule, write it down. Write down the formula, write down what it's called. It will help you remember. Okay, so let's take the derivative of the first. Our first derivative would be 3x squared minus 8, and then we multiply it by g, which is x squared plus 4. Then we take f. F is x cubed minus 8, and our derivative of g is 2x plus 0. So if we clean it up, we're left with 3x squared minus, ooh, I did a mistake, didn't I? The derivative of a constant is 0. That's what I get for going quick. So we just have 3x squared, and g is x squared plus 4, plus f is x cubed minus 8, and the derivative of g is just 2x. Okay, let's multiply it in. And yes, even after all that schooling, I still have to draw those arrows, otherwise I make silly mistakes. So I have 3x to the 4th plus 12x squared plus 2x to the 4th minus 16x. Let's combine some like terms. I see we have some x's to the 4th power. So 3 plus 2, we have 5x to the 4th power plus 12x squared minus 16x. Okay, next problem. Let's go ahead and multiply these two. Well, why multiply when we can use our product rule? That says our derivative of our first times our second plus our first times our derivative of our second. Notice how I write it down every time we do it, just to give us some structure. So let's rewrite this because that radical throws me off. So let's write it as x to the 1/3 power. And I'm going to multiply that by that x squared plus 1. Now, if we think of this as our f and we think of this as our g, we can easily apply our product rule. So our first derivative, we bring down that 1/3. So it would be 1/3 x, and then I have 1/3 minus 1, or 3 over 3, which gives us negative 2 over 3. Okay, and my function g is x squared plus 1. All right, next one I want to take my function f, which is just x to the 1/3 power, and apply my derivative of my second. So we have 2x plus 0. Okay, let's multiply it in and clean it up. So that we have 1/3. Now we add that negative 2 over 3 and 2. So negative 2 over 3 plus 2. We need a common denominator, so that would be 6 over 3. That would give us 4 over 3. X to the 4 over 3 plus 1/3 x to the negative 2 over 3 plus 2x. Well, we have to add 1/3 plus 1, which is 3 over 3, so 4 over 3. And then times 0, that's nothing. Okay, we have some like terms. So that we have 1/3 plus 2, 1/3 plus 2, that gives us 6 over 3, 4 over 3. So we have 4 over 3 x to the 4/3 power plus 1/3 x to the negative 2 over 3. So we can write that negative exponent below so that I have 4 over 3x to the 4/3 plus x to the negative 2, or not negative anymore, 2/3. I know those exponents that are fractions kind of build up a lot of work, but if you show your work as to how to add and subtract those fractions, they'll keep you from making silly mistakes. Okay, now we see a fraction. Let's go ahead and find the derivative of this using the quotient rule. So what is our quotient rule again? We take the derivative of our second, no, our second function times the derivative of our first minus our first times the derivative of our second, divided by our denominator squared. So our quotient rule is a lot like our power rule. Our first and our second, but we're adding our denominator squared. Notice I changed up the order. They're being multiplied. I just like to write f first because that's how I have it in product rule. Remember, it's the same idea with a minus. Now you can go around this one and not use any of these rules, but let's do it for practice. So if we think of our numerator as f and our denominator as g, we have the derivative of our first is 0 times my function g, which is x cubed, minus f, which is 2, times my g prime is 3x squared, divided by our denominator squared. So I have x to the third power squared. Let's clean this up. Well, anything times 0 is 0, so we're left with negative 6x squared divided by x to the 6th power. Now we can clean this up. Remember your quotient rule of exponents? You get negative 6 with an exponent of 4. And that's our derivative. Okay, this one has a lot more work to it. So label your numerator as f, your denominator as g, and according to your definitions, your quotient rule is f times g, derivative of f, minus f times g, the derivative of g, divided by your g squared. Okay. Your f prime, your derivative of f, is 2x plus 3. Your function g is x squared minus 1, minus your function f is x squared plus 3x plus 4 times your function g, which is x squared minus 1. All of which will be divided by your denominator raised to the second power. There we go. We have set up quotient rule. Let's go ahead and clean this up. So I need to go ahead and we need to FOIL all this out. So that we have 2x cubed minus 2x plus 3x squared minus 3 minus, and all of that has to have a minus, so I'll save the minus. And let's go ahead and multiply all this out. So we have x to the 4th power plus 3x cubed plus 4x squared minus x squared minus 3x minus 4 all over x squared minus 1. Actually, I made this much more complicated. Ignore everything I said. Let's erase all this. Okay. Notice that we can factor out that x squared minus 1. I mean, yes, you can always multiply if you don't see, you can factor anything. But we can factor something. We can factor out that x squared minus 1. So we have x squared minus 1 times, and we're left with 2x plus 3 minus x squared plus 3x plus 4, all of which is divided by x squared minus 1 squared. We can divide one of these out and thus make it to the first power. And now we have 2x plus 3, and we can distribute that negative, have minus x squared minus 3x plus 4 divided by x squared minus 1 to the first power. So if we clean up our numerator, we have negative x squared minus x plus 7 all over x squared minus 1. And we found our derivative. Next problem, find the equation of the line tangent to the graph of f of x equals x squared plus 1 over x squared minus 4 at the point 3 over 2. Okay, well for this problem, we see that our derivative will help us find our slope at the given point. So let's start off by finding our derivative. Now we need quotient rule to find the derivative. Now I always tell you, write down your rule. That will help you in the future. Our quotient rule is f and g minus f and g divided by g squared. We take derivative of the first and then the second. That's how I remember it. Okay, so let's apply quotient rule. Our first derivative of our numerator is 2x, and then our denominator is x squared minus 4, minus our numerator is x squared plus 1, and our derivative of our denominator is just 2x. Our denominator is x squared minus 4, and I'll write it as quantity squared. There we go. That's our quotient rule. Let's go ahead and clean it up a bit. So I see that we have a common factor, that 2x. And you don't have to factor it out from the get-go. You can work it in. You'll still get the same answer. So we have 2x, and then we're left with x squared minus 4 minus x squared plus 1 all over x squared minus 4 squared. Okay, well I can distribute that negative so that I have 2x times x squared minus 4 minus x squared minus 1. Okay, we can clean it up. So I have 2x times x squared minus x squared, that's gone. And we're left with 4 minus 1. Negative 4 minus 1 is negative 5. So that just gives us negative 10x all over x squared minus 4 squared. So that's our equation that will produce a slope, our desired slope. We have our point given of 3, 2, let's go ahead and plug in 3 to find that slope. So I get negative 10 times 3 divided by 3 squared minus 4 squared. That gives us negative 30 divided by 9 minus 4. That gives us 5 squared. So I have negative 30 over 5 squared, which is 25. That gives us negative 6 over 5 as our slope. Okay, now let's use our point slope formula. So that we have y minus 2 is equal to negative 6 over 5 times x minus x1, which is 3. So we distribute in our negative 6 over 5. I have y minus 2, negative 6 over 5x, plus 18 over 5. I add 2, left with y equals negative 6 over 5x. Let me do some work on the side. So I have 18 over 5 plus 2. I know that should be 10 over 5. So that gives us 28 over 5. And there we have it, our equation of our slope at that given point. All right, so what did we learn in this section? We learned the quotient rule and the product rule. That's section 3.4. Thanks.